Recording. All right, demo day. Lots of stuff. There's things that are happening all across the board, from things happening in optimism retrofunding land, all the LLM stuff that we're doing, and we're now doing way more front-end development than we used to. I'm not even sure that we have time to demo everything that's been going on, but why don't we start with one? So let's do Phoenix first, just because that's going to affect everybody. So we're using a platform called Phoenix Arise. That is our platform of choice, at least for now, for prompt engineering and evaluations. So, Carl, you have the login for this, right?
I have not tried to log in. I'm guessing it's in 1Password, though.
Yes, you should log in. There are multiple projects right now. Don't get too don't get too confused. Right now, the projects are really just to kind of separate out different traces. Traces are super useful because it will help you debug things. So, sorry, you haven't played with Phoenix before, right? Is it worth doing like a 10-second primer of the different stuff that's in here?
I think it is.
Say that again.
I think it is. Yeah.
Yeah. Okay. So traces are like the most useful thing, honestly, because it will break down train of thought. So for any particular run, you'll see everything that the agent tries to do. Here's a good example where okay, it's not a great example because I think it was just me saying hello. But let me go to another one that's actually more interesting. Okay, so here's a user message where I think somebody probably just clicked one of the example in OSO chat of like, show me the top 5 projects by star count. And so you'll see that these are actually all the tool calls that were made by the React agent. Tries to get schemas, tries to list tables, tries to query OSO. This is the query that it actually ran. And then this is the response that it actually gave, right? So this is end-to-end what it's doing, but then you can actually drill deeper, right? So this is the initialization step. This is the setup step. This is the agent step where you can start to see its chain of thought and reasoning. So it's like, okay, the user's talking in English. I need to find a table that has project information, yada, yada, yada. And you can go step by step, every little thing that it's doing. This is the default prompt in the React agent today. So you can see how we enumerate in the context all the tools it has access to, including list tables, schemas, get examples. It's a very long prompt. And then you can start to see the agent do thing after thing after thing. Every blue color is like a step of what it's doing. Every yellow and orange color is either a function call, like here we get a list of all the tables. So this is us calling our MCP server to get all of our tables, or it's calling Gemini to give it something, right? So Gemini might be, in this example, I think we gave it the entire list of tables and then asked it what to do next. And you can see, okay, the assistant thought maybe projects V1 is a good candidate or something to check out. And you can actually walk through every little thing. This is why it takes about 15 seconds right now for it to give a response. It's quite slow. One of the things that we want to do is accelerate this. One of the reasons why it's so slow is because this is the simplest agent that we have. The default agent, I'll show you how we implemented it. So if you go to our code base, all of our agents are in warehouse, OSO agent. It's currently in OSO agent. We're now starting to write different types of agents. So I have the React agent is the default one. It's probably the smartest one so far. And then we're working on this one called SQL agent, which we're trying to reduce the number of steps that it takes so that the end-to-end latency is faster. So the React agent, we read the React. Wait, did we read the React paper?
Yeah.
We did read the React paper. Okay, cool. So one of the things that's really cool about Llama Index is that it implements the React algorithm for us. So For us to create a React agent was actually very simple. All you need to do is instantiate the React agent with a set of tools. In this case, we have like a few tables or a few tools that we give it access to from our MCP server, and then an LLM, and then it just goes. So it was like less than 20 lines of code. You can create a React agent. It's reasonably smart. It's just like, and it tries to do all of this reasoning. So that is what we're watching here right now, is like the React agent without like just a list of tools, like no hard coding of schemas and whatnot. Like just figure it out. And this is it figuring it out. And it does a reasonably good job of figuring things out, considering this is like 20 lines of code with very little like specialized context. I think we can do better. But anyway, any questions so far? This is like a 30-second run where it's like, sometimes it gets really stuck, where here we're like, what are the tables that are available? And then it gets stuck into this like 30-second loop where I guess it does figure it out, but it just took a while. Any questions on traces so far? Pretty straightforward. It's automatically instrumented. The thing that's really nice about using something like Llama Index right now is that it will automatically trace anything that you do. So we set up tracing here. Not super important how it works, but there's this magic thing called the Llama Index instrumenter. So as long as we're using the Llama Index framework, it will instrument anything. As long as you're using Llama Index abstractions like tools, LLMs, query engines, and workflows. As long as you're using these like standard Llama Index abstractions, it will instrument it with traces so you can watch what it's doing. Cool. So that's tracing. Any questions so far? So we don't use this yet. There's a lot of features. These are the 4 core features. We don't use prompts right now. Right now, all of our prompts are actually hard-coded in text files in our repository. I'm okay with that. I know other people do that as well. And the reason why I'm okay with that is the way that we do versioning right now is through commit SHAs. So that seems to be the easiest way. But you might find it really valuable and helpful to create prompts in this user interface, because if you create prompts and prompt templates in here, the playground feature is kind of nice. So imagine that you're trying to figure out, okay, I have 2 system prompt templates. Which one is going to perform better? And I just want to get an intuitive feeling for that right now. Yes, you could do evals end to end, but really the lighter weight thing to do would be to create these prompts here and then go into Playground and choose your model. So we typically use Google AI Studio. We're currently using a Gemini algorithm. Thankfully, I think that is all set up to the same billing. If you're logging into our Google AI Studio, it should be connected to your billing right now. And all of our credits, which is the more important part, I guess. And so you can just select one of the prompts that you created in here. Obviously, you don't have any prompts right now. I haven't really been using it, but I think, Carl, you might find this really useful. And then just play in here, and you can give it different context, right? So you can have a bunch of you can create your own fake user log in here. Of like a chat history, and then kind of replicate what you try to get at. So that's the playground. Anything that you do in here, obviously we're going to want to get it into code eventually, but it's a good place to just kind of experiment with prompt engineering. Pretty straightforward. Then there's data sets. So one of the realizations that we came to this sprint is that we're going to need multiple data sets. It's not like a single data set. The only data set that we have right now is text to SQL. That's effectively implicitly what Dot does is in their evaluations is text to SQL. The reason why that's significant is because the expected output is SQL. Eventually, we will also have other data sets for, let's call one an end-to-end data set. Eventually, we'll have an end-to-end data set where there are things that users say at the very beginning, and then there's things that they get on the other end, which might be a visualization. It might be some kind of prose. It might be some kind of answer that's not strictly a SQL query. But for now, let's just start with text to SQL because we're just trying to do information retrieval that's already inside of our data lake. So What does that mean? Implicitly, what this means is that the only things that I want to see in text to SQL are things that are already in the data lake. If it's not in the data lake, you can't evaluate it. Eventually, we want to do semantic research, right? We want to do other things. You've mentioned before that we want to do like crawling the web and GitHub and READMEs and do like information augmentation. Those will be separate data sets in the future. But like for each unique function, we're going to have a separate data set. All right, let's just focus on text to SQL first, because it should, in theory, be the easiest. Hard enough already. I want to get to a higher accuracy level here. So when you go to text to SQL, you can click on examples. Right now, these 5 examples come from Dot. If you click into one of them, this is just the convention we have right now. It has to be a JSON object. That's kind of annoying, but I guess it kind of makes sense. And so the input is always a question field, and then the output is always an answer field with some SQL. And metadata is really valuable. If you have time to help me populate metadata, I would recommend it. I only did it for one here, where it's like, okay, I can set a priority level. I can set a estimated difficulty level. These are the, if you remember, Evan started like a categorization mechanism in his Google spreadsheet. This is where you would put that. The reason why this is valuable is because in the future, I want to be able to say, so here's like an example of an experiment run. If I go into my experiment, I want to be able to say, okay, just give me the examples where the difficulty is easy, right? Something like that. So I want to be able to run subsets of examples in the future. The more metadata that we have, the easier we can do that. So I know it's a little tedious, but to the extent that we can have some convention for metadata, please help me do that. Okay, so these are all the examples. Once we have the examples, then we can start running the experiments. In production, there are no experiments right now. I've only been running them locally because of that bug that Ruben helped me fix last night. But eventually, the experiments will start popping up in here. Brief digression. We do have a Discord channel where you can run evals. So when you run evals, there's only 2 commands right now. They all start with a bang. So you can do bang hello, and it'll say hello back. And you can do a bang run eval. If you do a bang run eval with no arguments, it won't know what to do. If you do a bang eval with a test name, so we have a directory now of experiments that exists in code as well. So if you go to evals, there is an agent registry, and there is also an experiment registry. The registries have unique names, and right now we only have one experiment called text to SQL. The experiment is defined in code, so that's why I'm just pointing to where it is right now. It's a function that gets run. So we only have one experiment. In the future, we'll have multiple experiments. So for text to SQL, the way that you run it is you go to Discord and you just say, hey, run eval text to SQL. And it'll trigger a background job where the agent starts running this experiment now. You'll see here, obviously, this is me running it locally. So in the future, this will be a link to our production Phoenix. And it'll link you to the experiment, and it'll give you a rough summary of what happened. So this is a terrible example. This is the way that you interpret this is right now we only have one eval, and it just checks whether or not it's a select statement. And there's only one example, right? And examples equals 1. So it only had one run. It had 0 errors, and the score is 1 because it indeed created a select statement. So our average score right now is 1. As you have more examples, this will become a number between 0 and 1, right? The score. This is another bug that I need your help with. I'm not sure why production Discord bot isn't responding. You'll notice here I wasn't able to get the production Discord bot to respond. I can get my local Discord bot to run, so we're gonna have to debug this. I'm not sure what's going on here. Okay, we can also deep dive in. So when you click on that link, it will it'll bring you to one of these experiments. And so if you click on the data set, experiments are bound to a data set. And this is my, you'll notice this is my local Phoenix running. So I only have one example in here right now. Eventually, we're going to move everything to production. So don't even worry about running local Phoenix because it's just annoying to get these things to be consistent. But I only have one example, and you'll see here now, okay, there are multiple evals that are running. So I want to like distinguish between an eval, an experiment, and an example. An example is one test case. An experiment is a set of evals that I run on all of my test cases. So I run 3 different evals. The first eval I told you already just checks whether or not it's a select statement. They all generate select statements. Great. So that's what this one represents. Then we do SQL query similarity and SQL result similarity. SQL query similarity is just string comparison. How close is the generated SQL to what my correct answer is? And it just gives you a number between 0 and 1 that is like a rough string comparison between the generated SQL. The SQL result similarity is similar, but it does that for the result object. So I will call the query engine, get the results back for both my correct answer and for the generated answer, and then it'll check how close those two are. It's not generating very good stuff right now. So 0.2 basically means that, you know, it's not very similar. I would expect this to be significantly higher if it's actually doing the right thing. Yeah, that's how you interpret these. You can click into one of them. This is actually really valuable because with LLMs, like, it's designed for a world where there is no correct answer. And so the way that you look at this is that you can do multiple experiment runs at a time. So let's say here's run number 6. I'm looking at run number 6, and I want to compare it to runs number 5 and 4. I can check all of them, and I can see that with this input, this is the answer I expect to see. And this is what each of those experiment runs actually generated. So in the future, when we're actually producing prose and not SQL statements, this is really valuable because I want to see, like, in each of these runs, like, can I just compare what it actually output? And then it'll give you a little chip when you run it through an eval, what the score is from the eval. But it is useful to just see what is the LLM generating so that I can compare them. And you know, when we start to do things that are not SQL generation and just like text generation, this is how you kind of compare the results from them. Okay. Any questions so far? Is this pretty straightforward? Okay. So yeah, I think this examples thing is where I'm going to need the most help. Cool. So this is, I guess, more of like I showed this part to Reuven already yesterday, but I guess this is more for Javi and Evan and Ikaro when they get a chance to watch this offline. I just want to briefly share how things are currently organized right now. So in the agent registry, we are basically hard coding and creating a bunch of different agents. They're poorly named, so we should probably give these code names that actually represent what we're trying to do at any given time. But we're actually creating and instantiating every possible agent that we care about in this registry. And you can select which agent you want to talk to right now in config, but in the future, you want to be able to do this at runtime with some kind of header or something like that. The way that you configure this right now in the command line is you can do it with this agent name config variable. So this is just, you know, some kind of addressing, right? So I can create a bunch of agents in here. As I mentioned, this is the React agent that we saw before. This is the SQL agent that we're currently working on right now. There is multiple layers of abstraction. So there is the LLM itself. You can also create what's called a structured LLM, which is really valuable, which is to say, I want the LLM to only produce things that fit this Pydantic model. And then the agent is specifically a way that you can organize memory, context, like tool management and handling tool responses, The agent itself is more than the LLM. It's a collection of the LLM and a bunch of other stuff around it to do other work. And then there's another abstraction that we haven't even started implementing yet called a workflow, which is what happens when you put multiple agents together. You want to run and process an input, but you want to orchestrate these agents working together to actually produce the end result. So right now, all of our workflows are single agent workflows, but in the future, we'll have multi-agent workflows. And then our experiment registry, I think I mentioned earlier. Yeah, right now we just have text to SQL, but in the future we'll add more. I think we are like, so yeah, I'll stop here and from demo day. But from a planning perspective, just as like a teaser, I think there are all sorts of other experiments that I think we should be running. Much more data sets that we need to have. So I think across the board we need help implementing those. But then also, we are at a point where we are ready to start implementing different types of agent architectures, as long as they can be evaluated in some way that meets these evaluations. But let's talk about that in planning. Yeah, let me stop there. The only other thing that I was going to demo is stuff that I already have a YouTube video for. So I'm just going to briefly allude to this. Like, this was a YouTube video from earlier last year. If you go to our channel and you go to playlists and you go to tutorials, I gave a half an hour long demo of a bunch of stuff that we did in the front end. So if you haven't watched this yet and you're curious how to do front end development, it shows two things. One is the new organization feature as a part of OSO. So there's member management. You can add members, you can remove members, you can create organizations that organize groups of people that want to do something. All of our billing in the future will be attached to an organization. So this video will show that demo, but then it will also, more importantly, show how that feature was built. So in the future, if you want to add new features to the front end, this is the workflow by which we do that. This is exactly the workflow that Javi's using right now to set up Stripe billing. And we're going to add more and more stuff in here in the future. So yeah, go watch that separately if that's interesting. This was part of the same sprint, so I think would have been way too long to do as part of this demo day. Any questions? All right, cool. If there are no questions, then maybe I'll just screen share Javi's Loom while Reuven is getting ready.
Oh yeah, I'm ready whenever now. So yeah.
Okay, cool. I'll just screen share this anyway. I have it up.
Yeah.
I always get confused whether or not the audio will work if I play locally. So please tell me if you can't hear this.
Hey everyone, it's Javi from OSO. Sadly, I won't be able to make it today.
Oh wow, it's at like 2.5x.
Oh yeah, let me do 1.5.
Oh yeah, it is. Wow.
He already talks really fast.
Javi from OSO. Sadly, I won't be able to make it today to the demo day. And that makes me a little bit sad because actually this sprint is packed of features which are really visible and people can appreciate from moment one. And I want to show you in this quick Loom an overview of what I've been doing in the last sprint. So mainly my focus in this last sprint has been around spinning up a credit system, which means that we need to actually implement a lot of issues first.
I think slow down to 1.25. It gets choppy, I think, at that speed.
Is it a volume issue or is it a choppy issue?
Volume is low for me. How about
Volume
you?
is low. I did turn my volume way up, so in order to hear it, yeah.
Let me try moving my mic
Let's
closer.
try 1.2 though.
First, before fully tackling the credit system, we need to find a way to represent organizations. We need to find a way to start measuring more analytics. We need to have a way to buy credits. We need to have a way to see credits. We need to have a way to track these credits. And my work has been mainly in those fields. So here's the issue that we're using to track everything. This is the Epic, and it will get closed pretty soon. There's not a lot of things that need to be done, but let me actually show you how it is. So if we go here to our website and we click on login, I log in with my Google account. So I'll go here, here, and here. And now if I'm here, you can see that when you click select organization, there's one organization that has been created for you automatically. This is one of the SUPA-based migrations that I've done, which means that every time you create an account, a new account, it will create by default one organization. If we go here to my organization, you will see that there's this billing tab new. And if we click on it, you can see all of the history of all my transactions. So for example, I've been doing some chat query previews in the API v1 chat. Currently, we only consume 1 credit as of now, but this will change in the future since we are having this preview moment. You are able to actually go into negative to default. We don't enforce that limit yet. This is more of the first iteration. And I want you to note these 85 credits. So if we go, for example, here to the SQL Studio and we say something like, I don't know, hello, something just so it's like a pretty quick response. And if we go back to organization and billing, we can see that now we have 84 credits. And now at this time, which is currently now, an API v1 chat endpoint query has been created. Nice. But the thing is that we will eventually run out of credits. How can we actually buy more? Well, there's currently a bug in Plasmic, which I'm trying to tackle regarding SUPA-based organization and SUPA-based sessions, which doesn't persist them across redirects. So for the moment, it is coded here. So as you can see here in the credit management, we have 84 credits, and here are the packages we can buy. Let me copy the credit card here, which is the success one. So I will copy this credit card. I will select $5, and I will start here. So now here I can put something like my email, caribalabs.co. Let me put this credit card like 1, and let me put something like 30, and 5 on 1, and half. So now, I mean, you can choose dollars or euros if you want. Doesn't matter, it's a sandbox. And now, as you can see, the transaction goes through and works. And the payment was successful. So if we actually go back to our dashboard, here's the bug is that I need to log in back again because the session is not persisted, and that's the bug I'm trying to fix. If we go back to the dashboard, we can see now that we have actually here in billing 184 credits, which means that the transaction went through, and we have here the purchase of all the credits we can now use in all of our things to actually consume these credits and start keeping tracking and usage. So how is this implemented in the code? So we have these SUPA-based migrations. For example, this one creates organizations from individuals. This one is the one which tackles all of the credit system. This one is the one which auto-creates organizations. This one is one which creates purchase intents, like when you want to buy something and you create like a Stripe checkout session. That is what this tracks, so we can keep track of like if it's pending, completed, canceled, or if it expired. Then I also created this Stripe client for you to have like all the credits and all the intents. And here's where all of the code for like the billing page is set up. As you can see, we have all of these single components, so we can actually import them in Plasmic and use them rather easily. For the moment, for convenience, they're now in React land because I want to fix the bug regarding the session. And here we have the route to check out Stripe, the webhook route, which actually creates all of the credit transactions. And here in the OSO app, to connect with Plasmic, you can get your purchase history, get your credit packages, and buy your credits. I'm running out of time, but I hope that gave you an overview of everything. This is not deployed in production yet. I still need to fix that bug, but I hope that you guys liked it. And any question, please leave it around. I'll be super happy to answer it. Ciao, ciao.
Nice. Amazing.
Looking good. Looking good.
Yeah, we can definitely hire a designer soon, but not any of us. The fact that
multiple styles, yeah, it's a design choice. It's like, ooh, you go to billing and it looks gorgeous.
But yeah, hosted Stripe checkout, definitely the way to go. It was pretty fast that he got this together in a sprint. That's awesome.
Stripe, so nice. Yeah.
Awesome. Cool. You want to go next, Ruben?
Yeah, let's do it. So okay, let's start with geez, hold on. Did I never allow? I guess I must have upgraded my system. Hold on, I may not have allowed Chrome to share the screen. Give me a second. Okay, I'll be right back. Actually, I gotta quit and reopen. So hold on, skip me. My bad.
Do you want to go, Carl?
Yeah, sure. I will stand in. Hopefully this works for me. Let me share. I'm going to do the entire screen because I'm going to be going back and forth between command line and... Okay, great. Can you see?
Yep.
Yeah.
All right. So I think the first thing that I will share is that the latest results for retrofunding Snapshot 3 were released on the 19th, so that's about 8 days ago. At this point, we've reached the midway of season 7. There's 6 snapshots in total. We have done the first 3. If you are a top project that has received the max for every single month, April, March, February, you would have received 200,000 OP total. So there's a few projects here. On the on-chain side, Aerodrome, Uniswap, Velodrome have been pretty close to the top. And then on the dev tooling side, a bit less competition. There's a few standouts like Hardhat, OpenZeppelin Contracts, Ethers, VM, etc., that have been at the top of the charts each time. So those are the results. There's some cool dashboards here that mostly people on the OP side have been using for quality assurance. So if a project says, hey, where is my funding? Why didn't I get any funding? You can look it up and you can get the latest results. You can see its metrics if it's an on-chain project. You can see the dev tooling graph if it's a dev tooling project. And that has been reducing the amount of inbound that we've been getting. So that's on the dashboard side. Behind the scenes, let me just share. This is from the retro funding repo, so it is not in the OSO space. But we basically created a framework where people from the foundation, other data scientists, they can come in and they can make changes to algorithms. They can test with dummy data, and they can hopefully refine the algorithms that we use. So I'm going to, let's say that we are getting ready for retro funding 4, the 4th measurement period. I'm going to drop this script in here and change it to, oh, sorry, let's not do that. Let's do, let's grab the latest snapshot first, actually. Okay, so if you were getting set up, you would have to put in your API key. I've already done that. So I'm just going to go right in and grab the data for the most recent snapshot. So hopefully this works. It's going to be querying data from OSO and setting up a new snapshot and downloading all of the data. This should take 30 seconds or so because it's like 5 or 6 different queries that it has to grab. You can see that these are all being dumped over here. Yeah, here's an example. These are projects that are coming in for the dev tooling round. You have DeFi Llama, OpenZeppelin, etc. Okay, so it's finished. It has created a new directory here with the M4 data. That's the 4th measurement period. So now the next step would be to come up with a weighting file that we want to use. If I could do that now very, very quickly, I'm going to just copy the one that we have from M3. I'm going to drop that in here. Let me paste it. Not making any changes. I'll just update these numbers here. Use those. Okay, everything else is basically going to be the same. And now I can run the scenario. Let's do this one. And it will effectively execute. Oh, we might not have the May 2025 data finalized yet. So I'm just going to change that back to March and April. Okay. Okay, so it worked. We now have the results. This is the result snapshot. We can see what happened here. And a lot of the work that people want to do is test out using different metrics, test out using different weights, and experiment with what if this project applied to the round or didn't. And so this is basically the scaffolding for people to make those kind of analyses and recommend improvements to the algorithms. And yeah, there's a few changes that are being planned for the next snapshot, which will be in a couple weeks. But yeah, that's basically it. The dev tooling one is a bit more robust than the on-chain builders one because it includes more sources of data. It has a more complex algorithm. But yeah, this is all you need to simulate your own retro funding results. Any questions?
Cool.
Curious, like, I mean, the intention of putting this all in this repo is to, I guess, both give people more confidence in terms of where things are coming from, but also give the community the opportunity to tweak. I'm just curious, like, what are the most interesting community tweaks you've seen so far?
I would say there haven't been any interesting community tweaks that we've seen so far. The only person who's really gone in with a vengeance is Jonas, and has double checked all of our work and also done his own experiments and then made his recommendation for what he thinks we should consider. I think going forward, it's probably going to continue to be like that, where we basically collaborate on algorithms. There can be ideas for things that the community would like to see, but I don't think that there is going to be a large number of data scientists that are actively proposing tweaks over here. I think it'll be in other parts of the stack.
I guess, yeah, you can interpret that in like a couple of different ways. That would be not a great result if our expectation is that the community ends up eventually taking ownership over this. But it could be a perfectly fine result if you know, we've actually built a lot of trust in this process by doing it openly, and you know, people generally like the results that are coming out already, and there's just like a high satisfaction, you know, rating or whatnot. Curious what's your current impression of that?
Yes, I think right now there's much more of a focus on being able to iterate rapidly and go from having a pretty bare bones infrastructure for testing these things out to something a bit more robust. And right now it is more important, I think, that we rapidly improve algorithms than there be a community of people that are proposing improvements.
But what is the current impressions of the algorithms themselves?
In general, I think that people are quite happy with it. The types of debate that we are hearing is more focused on you should be rewarding consumer apps more than DeFi apps.
Oh, I see.
Do what is being rewarded this way. I think people are saying, yeah, this makes sense. Again, there's still maybe 5 or 10% that can be optimized, but I think that it's a lot better than it was 3 months ago, put it that way.
Okay. Yeah, that's pretty positive. And it's more of the subjective stuff as opposed to the objective measurements. Like,
yeah.
I mean, I wouldn't be opposed to more constructive feedback on how to improve the objective measurements. It's just it sounds like we don't know where to get that kind of who's gonna be like who's the right stakeholder to push us in the right direction in that regard, aside from Jonas, I guess.
Yeah, so I think that what if we look at the on-chain builders, let me just switch back over to this, right? And you look at who's on the top of these lists, right? There really aren't any surprises here, which I think means that it is working as expected. In the sense that retrofitting starts to reward impact, which should be obvious in retrospect, right? Now, one could argue, you know, I think Aerodrome should be receiving less funding than Aave, or the opposite, right? But in terms of the signals that are being used to quantify their impact, I think that part is feeling pretty solid right now.
Yeah, two things that come to mind here. One is anomaly detection. So, you know, I can see the bias of just looking at the first 20 and being like, that looks reasonable enough.
Right.
And then, you know, not really looking for further after that. That's probably fine, but like, you know, there is a long tail of people that probably get, you know, somewhere in the I don't know, the 4 to 5 figures worth, right? Like very long tail. And you know, we don't have any real auditing mechanisms right now for that kind of stuff. And so I'm curious, you know, yeah, it's not trivial amount of money, right? We're still talking about like quite a bit of funds that get sent out in the medium to long tail. Probably worth some thought into like what quality controls look like there. Whether, you know, and how do we detect if somebody starts gaming things in a way that we don't like? If they're hidden somewhere in the medium to long tail, like how do you even notice? That's kind of what I meant by anomaly detection.
Yeah. I think right now there tend to be two types of anomaly detections that are happening. Number one is the community will say, hey, why is this project so here? I don't think it's a good project. And that comes up. There were actually a few examples of that came through in the first round. And then in subsequent improvements, they've now really dropped to the bottom. The second thing is more just movement from one period to the next. And in those cases, we were tracking these deltas over here, and we were tracking new projects to come in. I would say those prompt a more thorough review each time. Yeah, we either see a new project to make sure that it makes sense, and if there's a big movement round over round, what could be going on there?
Yeah. Okay, cool. That makes sense. And so we are actually auditing any major deltas regularly.
Yes. By we, that is myself and a few people from the foundation right now.
And this also implies that the top projects are getting, am I reading this right, like 800K per year?
Well, this is over 6 months. So this is over 3 months right now.
Yeah.
Yeah, but this is intended to be continuous going forward.
Right. Yeah, so 800K per year, right?
Yeah, so it's good funding.
It's not bad. It's not bad for projects that are just, not focused in shipping anything particular to Optimism, right?
Right. Yeah. I mean, any on-chain builder, it's pretty clear what their value they're bringing. I think going forward, there's going to be much more refinement of, drawing a ring around certain types of public goods and how directly those complement Optimism. More likely, what this will look like in the future is that there could be a more general set of libraries that get rewarded a certain way, and then OP-specific ones, and then potentially ones that are unlocking very, very specific utility, like wallet providers.
Cool. Sounds good.
Cool.
Let me show the next thing that I've been doing right now. So going back to December and January, we were working on a dependency graph for deep funding. Since then, they've also done their own data science competition. And one of the pieces of feedback that we got, we kind of knew this would be the case, but there's a few high-profile projects that said, hey, our dependency graph that you're giving us makes absolutely no sense. Maybe they are a Java project, maybe they're a C# project, which historically we haven't covered. Or in some cases, they are a TypeScript project, but they have a very, very long list of transitive dependencies, basically packages that other packages that they import are importing. And so we were asked last week to see if we could kind of clean this up and create a V2 of the dependency graph. So in doing so, I experimented with a couple different ways of getting different dependency sources. I think this is actually the best way of visualizing it. So we start with an initial 30 or so seed repos, and then we have 3 different ways of augmenting the data that we get from the GitHub API. Or sorry, we start with the GitHub API, and we have 2 other ways of augmenting the data that we get. So in some cases, this is an issue I think that Javi's encountering. The SBOM is just too big that it can't be returned by the API, and so you need to do like a manual snapshot of it or something. So in a few cases, we basically grab the SBOM and just parse it manually. The other thing is that if it's not one of the package managers that's well supported by the GitHub API, then you can point it to a list of package URIs. And I created a lightweight agent that will kind of read through that and extract what it thinks are the dependencies. This actually seems to be working pretty well. But basically, you have these 3 different ways of getting dependencies, and all of that is kind of rolled up into a consolidative set of dependencies like we had previously. Then we go in and look up on the OSO data. Do we know these packages? Have they been identified in deps.dev? Can we pull out the repo metrics from them? And then ultimately you generate a snapshot. So I'll give a quick demo of what this looks like if you want to see. We can try this with OSO. I don't know if this is going to work. Let's just test it. I'm doing this in Cursor because I think it's actually interesting to see how it prompts you through making things in the command line. Okay. Nope, it did not do the right thing.
Quick question. Did I know you asked Javi to help you with the field for direct versus transitive relationships. Did he ever end up getting you that?
He has looked into it. He hasn't pushed it yet. Okay. So here we go. So this is basically the command it should be giving me. Oh, okay. Got to do the poetry run. Okay, so it gives you the prompt. I'm going to say, yes, I want to add it to the repository sources. Okay, it's fetching it right now. And it came in and it grabbed a bunch of data. We can look at it now. Let's see what we have here. So yeah, so it's pulling in, I mean, we have a lot, so we have Python stuff. This does include the direct dependencies. I'll have to scroll down to find a few examples of those. Let me see. Do you know an example of a NPM dependency that we'd have? Anything that's in PyPy doesn't know. Let me just, okay, here we go. Yeah, so yeah, so all these Plasmic things, right? They are coming in as direct dependencies.
Mm-hmm.
And then I'm guessing there's some which are, you know, dependencies of Plasmic, which would come in as indirect ones. We have a lot of direct dependencies here.
We have a lot of direct dependencies.
Right. Here's the transitive ones, right? So ant design, icons, etc. Those are coming in as transitive dependencies right now, which you tell me, Ray, does that make sense?
Yeah.
Cool.
Makes sense.
So that's the first thing that it does. And then if we had an example of one that was a bit more custom, then it would kind of go in and grab that from, you know, we could specify the URI. I'll actually show you what that looks like. So this basically gives it a kind of a hierarchy. So it'll first look at the GitHub API. If not, then it will look at you know, local package files that we give it. And then finally, it will take a set of URIs that we give it. So here's an example of one, which is like a NIM project. And so it actually needs to go in and parse this URI here and get the data from that. And then finally, yeah, it just rolls all this up. I could run it now, but it kind of does a cleaning job where it goes in, looks in OSO. Do we have a GitHub repo that is associated as the owner of this dependency? It does some kind of semantic versioning logic. So it identifies, according to this package, who is the owner at that time. That was a fun little exercise, and identifies the right repo and then maps everything together. Any case, on Thursday, we sent this over to, I think it was 3 of the teams, so some of the consensus clients, and then I think there was the hard hat team or something. They looked at the updated graph and said, yes, this is much better than we had previously. They couldn't identify anything that was missing from it. So I think this could be an interesting way forward, at least for, so I don't think we want to do this across the board, but when it comes to being able to augment certain cases where there's an important project that we don't have the packages, this could be a way that we do that.
Where is the code for this? I don't see it in the deep funding org.
Yeah, it's in the insights repo. So sorry, here. Yeah, it's in insights experiments dependency graph v2.
Experiments dependence graph v2. Okay, got it. Cool.
Yeah, so that's that. We'll ship that off, and hopefully they will finish up the data science experiment. And the last thing that I was going to share, this is more under the hood for people, but a couple days ago I did a big PR which refactored the directory for the intermediate models mostly. And if you come in here, what you can see, actually, let me just go up to staging. Okay, so in staging, these are all organized by source. No changes here. If we go into the intermediate, and we go into the marts, we have basically 3 main levels. So we have entities, which includes artifacts, projects, collections, users, everything that is an event model. I think right now, all of the event models are going to be index the universe models. And then it's these metrics, which basically join the entities that we care about on events that we care about and produce metrics. So previously, we had a lot of models that would kind of come in and sometimes filter on projects, or they would use the event model to determine what belonged in the product set, which created a lot of, on the one hand, it would be very, yeah, it was very circular. it'd be computationally pretty intensive sometimes. So there'd be a few models that would take forever to run because they were going in and using a lot of information they didn't need. And so hopefully now this will, as we kind of push through some remaining changes, it'll make it a bit more efficient. But if we go into the intermediate models, this is where most of the changes have happened. We now have the same structure. So we have entities, events, and metrics. The entities are based on our top level entity types. So we have artifacts. Here, what will basically happen is there's going to be some registry. So it could be blockchain, DeFi Llama, GitHub, et cetera. And then that will all be unioned into Intel artifacts, or into artifacts will be the one that will have all of them. For the projects one, we'll basically have different sources of projects, and then that will be unioned up into in projects and into artifacts by project. And so that will be kind of repeated throughout. And then if we come to the events here, same kind of thing as each of these events. So if you take blockchain, actually that's probably not the best example. Let's take GitHub. We will basically have specialized event models, and then the two canonical ones that we get our time series metrics from. So the int events GitHub and the int events daily GitHub.
Sorry, I'm just like reading through the dependency graph v2 thing still. It looks like you're just fetching things from the GraphQL endpoint, right? Dependency graph manifests. But how does that? Sorry, I think I missed the part where you're talking about like how do you handle languages that it doesn't already have, right?
Yeah. So for those ones, there's a I can show an example of it. So it will come in and it will, I think it's in the analyzer one. No, sorry. It grabs here. It uses the, let me just find it, sorry. This one here. So basically, it uses Gemini to take a URI that I give it. So it could be like a set of, it could be a Gradle file. That was an example, right? So we have Maven, but we don't have Gradle. And so it basically comes in and looks up sorry, this isn't all shown here, but basically it will take, let me go back over to the command line. Sorry, data. Okay, so it will basically take a file like this, and it will pass this to Gemini, and then Gemini will basically parse through this and send back a list of dependencies in the same format as we have here. So it'll be in the dependencies JSON here. So we could look for, say, what's an example? Besu Maven.
Got it. So the GitHub Dependencies API does not have native support for Gradle?
No, it doesn't. Oh, sorry. Yeah, they come in here through Package Manager Gradle.
But you have to manually give it the full path to the
Exactly. I haven't done anything where it's going to scan the entire repo and identify things that look like package files.
Got it. Okay. That makes sense. So the seed for all of this stuff is in the repository sources. So did you manually write this, or
no? So all it does is you kind of start with if you just basically run, I could walk you through one of them, but you basically fetch the repo that you care about, and then it will start by getting what it can from the SBOM. If it is missing things, it will prompt you. I could do.
How does it know if it's missing things?
It will tell you what it gets back, and then if you don't get anything back, or you have something ready, then you can just choose the command line argument to pull from.
Oh, okay. So you do this in a REPL loop. like
Yeah.
through.
Yep.
Got it. Okay. Cool. So basically, if I had to summarize the steps, it's like give it a repo. It will try to get it from the GitHub API based on that repo.
Yeah.
You see if you like what you like. If you don't like what you like, then it will prompt you for the file for wherever to get the information, and then you'll ask Gemini to fetch. You'll fetch it and then pass it to Gemini to reproduce the data structure you want.
Yeah. So with all things, you have the option of giving it package files. So if there was like a Foundry file or something, you could pass that. It will first try for everything to get it from the API. If the API times out or it fails, then you have the option of manually providing an SBOM.
Cool. Yeah, seems reasonable.
Yeah.
So, and when people say they found this more reasonable, it's mostly because you just don't have it's mostly because you're mostly giving them direct dependencies now, which is what they wanted, right?
Yeah. So it's direct dependencies, and then for package managers that previously weren't supported, it has those packages too.
Got it. Okay. Cool.
I mean, there should just be an answer, right? This isn't like a judgment call. It's basically people looking at it and saying, "Yep, I know these dependencies," or "I have no idea what I'm looking at. These don't make any sense."
So for our pipeline, in terms of like what we actually want to implement, I think we do want the data fetcher to use the GraphQL endpoint to get this this relation field, but
yep, that's what Hobby's working on.
It's probably P2 to do any kind of like anything not supported by the API, like any kind of manual translation.
Yeah, 100%. I would say that this is, once we're in a world where we are getting data from spreadsheets and we feel good about that, maybe we want to do something like this.
Yeah. I mean, honestly, it does feel like a P2, but doesn't seem that far off that we have some kind of facility for anytime you have a GitHub repo, you can scan it for a set of well-known files, whether they're Gradle files or package JSON files or PyProject files or whatever. And then like, if you have a parser, use the parser. If you don't have a parser, toss it into Gemini.
Yeah.
Yeah, seems like a pretty, I mean, at that point you are basically building deps.dev, but like, it's seems pretty straightforward. It's just, just work.
Yeah. I would say that in doing this, I was also just experiencing, like, I didn't actually write any code. All this was vibe coded. So this entire thing, start to finish, was done. I know what to look for, but I tried not to write any code myself.
Nice.
Yeah.
Mostly in Cursor.
I did most of this in Klein, but then I would use Cursor for testing it as like a separate user.
Oh, okay. You're finding Klein to be better for your vibe coding purposes?
For complex projects, yes.
Really? Okay.
I mean, this isn't like complex, but it just had a lot of things that needed to be kind of orchestrated together.
Cool. Awesome.
Yeah. Okay. Yeah. So final thing, PSA. The dependency, or sorry, the model structure is a little bit different here. This didn't break anything for anyone else, right? I know that there was a lot of work that was happening over the weekend. Didn't bother anyone, right?
I mean, SQL Mesh just flattens everything anyway, so it's not.
Yeah.
Risk.
Yeah, SQL Mesh and DBT both flatten everything. So whatever.
Yeah. Okay. If you've been doing all those descriptions, it would have been annoying having your files move, but okay.
No, I was only doing that in the MART models, which I think we agreed not to move, right?
Yep. It's just the intermediate stuff. Open question. Like, this is probably a good enough holding place right now for just other stuff.
It's fine.
You fine with it? All right.
Yeah.
Sure.
Cool. Sounds good. Yeah. Sorry, Reuven. This is man.
No. Yeah.
Imagine if I actually demoed all the Plasmic stuff too, because that actually was this sprint. We'd be like an hour and a half in already.
It's okay. Yeah. So, shoot. Let me share my screen. I'm just gonna go.
Oh, right. You didn't go. Sorry, Reuven. I took a while.
Oh, no worries. Yeah, so okay. So the first thing, yeah, we did a lot of work to get these models all working with no gaps and stuff. This was like a big part of last sprint and early this sprint, sadly. But yeah, so okay, so a couple things on it. So a lot of the incremental models have now been turned into forward only, which Carl has now realized causes some issues, which is why you added
Wait,
this.
why did we make that change?
So it is in general a good thing. For especially for let's say for like staging GitHub events, like we know that this data pretty much isn't going to change. So a forward only just means that like even if you make like small little changes into this model, as long as it's not a breaking change, it just means that it's not going to go back and try and overwrite some old things, right?
If it is a breaking change, is it smart enough to go back?
So if it's a breaking change, that's why you have to have this on destructive change warn. So right now, the default behavior is to actually just say, no, you can't do this. So on a destructive change, it'll actually error, which is what Carl had encountered. Yeah, so if it warns, it just warns you like, hey, you're going to be overwriting some things that maybe you expected, not to overwrite, right? Which would be useful. So probably we could do this for all of them. We could probably just set them all to be warned because for the most part, everything for us is recreatable. It's just that, yeah. The one reason I wanted to do this is it also just, in theory, it will make a lot of our runs a lot more quick. Yeah, because it won't have to go back and reconsider, like, am I recalculating things, So yeah, so that was a big change. But if you that is only applied to incrementals, or at least I have manually applied this to incrementals that are not related to like projects or collections. So if you join on those things, I actually specifically ignore I specifically let's take a look like this one. I ignore that rule. Incremental must have forward only. So all of these are written as now as all of these checks that we've done, they're written as linked rules. So if you do something and it, like it violates something that I believe to be like not good practice, we've written linting rules here. So hopefully this just improves everything.
Awesome.
Yeah, what's up?
I realize now that I was doing the word like warn and allow in quotes. Is that going to not cause it to work?
Oh, that should be fine.
Okay.
Yeah, so in the model section of the model, this is all parsed by SQL Mesh, so it's not like SQL. So you're doing it in like single quotes or double quotes, like both of those are equivalent in this section. Yeah. So I believe at least.
Okay. Maybe that's why it wasn't working.
Yeah. I mean, I'll take a look at what the issue is. But I'm pretty sure we can just, as long as it's like not some really wild error, I don't think it's going to be that difficult.
And just to be clear, distributed changes are things that change a column name or remove a column.
Yes.
Okay.
So changing a column name, remove a column, or change a column type.
Sure. Yep. Okay.
Those are breaking changes.
Yeah.
Yeah. So a lot of this now is just going to force, us to write better, like write audits and other things, to have like better data quality. So hopefully moving forward, we have less errors on the sort of base parts of our pipeline, and it's mostly all of the new things that we build on top of it. So cool. Yeah. So yeah, now semantic models. So the semantic querying stuff, actually I can show you where this is all
Can you
defined.
show
right now.
where the
Oh,
can you show when we should and shouldn't be using the no gap audit?
oh, yeah. So yeah, so there's some cases. So if you expect it to be non-sparse data, that's where I would use it. The other cases right now that we do not support are things where you do like a weekly or like biannually, like in a weird time period. If you do like one that's not inherently supported by SQL, so not all SQL dialects support quarterly, or not all SQL dialects support, exactly like a weekly time range, So right now those aren't supported for no gaps. So those are just, currently forcibly ignored. But we can support them. We just have to write some additional macros. The other times that you may not want to do it, I know I did it in some of the superchain, like this the season 7 stuff. Actually, where is all of that now?
Oh, in specific.
Shoot.
Go to superchain S7 on chain. Yeah, there it is. Events by that one. Do that one. Superchain events.
Oh, okay. Events, yeah.
Yeah.
So this one, specifically, like some of this is kind of sparse data. It seemed like, like doesn't. So you can't enforce no gaps. You can now do, actually, the no gaps can have a percentage of success so that you can give it. So the problem with that is that it doesn't take, if for whatever reason on the increment that you are trying to add, like 100% of that is gone. Yeah. So it doesn't take that into account. What it actually should do is say, the minimum time window it needs to look at, and then also the minimum percentage, or the ratio of success in that percent in that time. But so those are improvements we probably should write into there, actually. And I realize I can make an issue for that. So but yeah, so if it's like source data almost always it's likely no gaps. Like the GitHub data, the any of the on-chain superchain data, all of that, likely no gaps. The other thing that we do to protect ourselves here is it gives a buffer of like a day. So any late arriving data, it doesn't worry. It'll do a look back anyway. So that's another lint rule that we've added is you have to have at least like about 4 weeks back of look back. So basically every time we run this right now, and we might make this smaller in the future, but it goes back about 4 weeks just to double check that things we aren't missing any really late arriving data. So.
And so when this happens, like let's take the example of where the superchain trace broke, right, for a week or something, right?
Yes.
What is the expected impact?
Yeah. So okay. So if something broke like a week ago, if you run it again, it will catch all of those, assuming that it got fixed and assuming it got backfilled, right, into the source data. It will, since it covers the last 30 days, let's say it's a daily incremental model,
right,
it'll actually catch all of that, and then anything downstream of that is also incremental also is linted to have required to have a look back as well now.
Okay.
So all of those things that are incremental will look back and ensure that they have those last 30 days.
And so a look back, because what would happen is it stopped for 1 day, but then it resumed, right? So it would actually identify there is one date in here that has been missing. I'm going to look back and fill that as well.
So it doesn't care. It doesn't actually know that it doesn't actually know that anything's missing. It just rewrites.
Oh, just rewrites.
Yeah.
Because the row count is different than what it's expecting.
Yeah, I mean, it doesn't. I guess it doesn't. It doesn't do any form of validation. It's just simply like, oh, okay, like 30 days. I will check that, and then or I will run all of that again.
Okay, so it's always regardless
Yeah,
of whether everything is good. It will just always be looking back and
exactly. Yeah. So that allows us, even if we're running this monthly,
right.
Or weekly or whatever, it's always just going to be very clear.
Okay.
About
if it fails, does it
Yeah.
everything fail or just that model fails?
So if it fails, it would just be that model fails at that moment.
Okay.
Yeah.
So everything else would run, and we would know that that one has not. Been
Well, sorry, yeah. If it fails, everything downstream of it would, not get updated.
fail
But
too.
if you were to rerun it again and it succeeded, it should be fine.
Okay, got it.
Yeah. Yeah. So I guess, to answer the question, it's really anything where you believe it's sparse data or it's not, what is it? And then if it's joined to projects and collections forces, some different logic. So basically, like over time, that will change. So if you're joining projects and collections, you should not use the no gaps or the well, actually, you can use no gaps, but you shouldn't do a forward only. You should ignore the forward only for sure, because you want that to change based on like future changes potentially. So
okay.
Mhm.
Separately, I was never able to get the type 2 models to work the way that I was.
Oh man, yeah, like that sounded so cool. It sounded like the thing that we needed. Yeah,
we should look into that because I noticed there's also
look into it.
The contributor ones, like the first engagement with a project has the same pattern, right? So there's a lot of these things where you want to identify, the first time a wallet or the first time a user or something.
Yeah, it might. Yeah, I think honestly, it's just it's probably just our like we've never had experience with that before.
Yeah.
So I have no idea. Okay. Any other questions? Cool. Let's take a look at these semantic models. Okay, so the semantic modeling, I basically modeled the API the development experience in a lot of ways around like what Cube is, except that you can do it against our or how Cube is defined, except you can do it against our data set, and then also it goes straight to SQL. There's no intermediate other data store. So what you do is you have a model registry. This is currently how things are set up. Eventually, maybe it'll be a little bit more clean or a little bit simpler, and we can put this into SQL Mesh itself. But you create these models. You say, hey, we have this collection. You give it a description. You can, so we have this is only currently doing the collections, projects, artifacts, and GitHub events. I haven't modeled any of the other things in here yet. I don't think that should be too difficult, but the reason why I wanted to do events as opposed to any of the like marts, because we actually don't have events in marts, as far as I'm aware, right? We don't ship all the events anymore. Like we don't have like time series events by artifact, getting shipped out anymore, as far as I'm aware. So the reason why I wanted to do this is I felt like that it would be a good show of like how useful this actually is for me. Because in theory, actually now with all of this, we can build like more intermediate models even, right? With just this semantic model. So let me just show you kind of how all this works. So we have the registry right now. This is just a testing registry, but I mean it's actually hooked up directly to our you can run this against the actual data warehouse. But if you run this, I don't know, I just hit that again because you have this here. You can actually describe the entire, semantic model, gives you all the dimensions, gives it these metrics, the relationships, any ambiguous relationships. So I'll talk about that in a second. So like you have to and from here, which the to artifact from artifact IDs. And then, I came up with a different way to disambiguate that, but we'll talk about that in a second. This is just some PyOSO stuff I was setting up here. Okay, so here's the actual query. So, we might refine this, based on how well the LLM is able to actually generate queries for this. Especially looking at this latest paper we read, it actually might be interesting to, use more of a like the, add blah or, filter by, that kind of like API. I don't know, but I'm curious. But for this, let's say, this specific query just gets the event type, the collection name, and then the total amount, which is the sum of the amounts. So if you looked at our model here, total amount is defined as sum self.amount, right? So then, and then you can filter by, I'd rewritten this earlier. You can filter then by either the from field or the to field. This is my syntax. So this is called, I'm calling this the through syntax. That's probably not a great name, but basically from the GitHub event.to, I'd like to go, through that to the collection, right? The reason is that the reason I have to do it this way, and the reason actually I think a cube forces you to write completely separate, like a collection entity, is that it's fairly ambiguous, because it is possible to do something like this. Hold on, let me copy this really quick. It is possible to do actually, let's say artifact.name collection.name, because there's no ambiguous relationship here, right? So so you would actually be able to get this query to work, and it would automatically join things, and group them all correctly. But because events has multiple relationships to artifact, we have to be explicit about that. So yeah. So when you do this, let me show you what. That was unexpected. What did I just print? Of course. Hold on. When I restarted my browser, something did not happen correctly here. Okay, so run this query. You get this. So this is semantic query. This is the semantic query. This is glot. And then let's do let's do Trino. Pretty true. Oh yeah, this is Marimo, by the way. I don't know if you
say, that was my meta question.
Yeah. I actually quite like it.
It's just Python, yeah.
Yeah, it's just Python. So you can actually see you can see the file, and it's just straight Python, which is really cool. Because then you can go into that and then use all the tools that you need to do in there as well.
Yeah.
Okay, so this is the actual actual query that it would run against the system. So, yeah, I've had to do some magic to figure out, like if you also had an event.from like through path, it would have to do like a completely separate join path. And all of that is actually all figured out here. So, yeah. So we can actually run this. So let me see. Two pandas. Okay. Oh, wait, hold on. Let me limit this. There's no way this will work well. Let me limit this to 10. And then GitHub event.time between 8/20/25 04/01 and
You're great at that. Okay.
040. Let's just do 2 weeks or something. Okay. And then yeah, I think that's okay. My concern is that we're going to run out of memory on on the.
Yeah, that's not too bad. That should be okay.
Yeah. Okay. So if we run this,
You could do an event type, but oh well.
Sorry, I think I missed. Where does the filter syntax come from?
oh, the filter syntax comes from. It's just it like so. The things you can do, I guess, are a model. The model, like the reference to the model, and then whatever you want to filter. So whatever SQL operation you want to do on it. So it's like I felt that SQL was descriptive like descriptive enough. All of these are ands. So all of the filters are ands. I guess there's no way to do or yet. I could do that, but I don't have that at the moment. So
Those are harder. We don't need ORs for now.
but yeah. Oh, I didn't print the data frame, so whoops. But it worked. It did an error. So yeah. So the one thing that's kind of cool about using this method, and one of the things I would love to be able to experiment with here is right now, yeah. So this is so cool. Yeah, right now it's obviously it's limited to the current known registry that I give it. But we can derive a lot of those relationships directly by going through SQL Mesh. So as long as the SQL Mesh stuff is also we can maybe tag certain things, I guess that we don't want to scan, right? Or but we can start from where the registry is defined and then go from there. But the nice thing here again is it does the proper joining. It does it understands all of that. And I think if we're able to combine this with what the LLM already can do with SQL things, we can sort of help it. They can work in tandem to make better queries. That is my current thought here. So yeah.
Cool.
Oh yeah. Other thing is I think I can actually rewrite all of the metrics using this now. So except for the lifecycle stuff. That's a little goofy. But yeah.
I disabled that recently actually, just to it was taking a while to run.
Oh yeah. Yeah.
We'll bring it back.
Yeah.
I think that was my common criticism of Cube. I'm curious, now that you've played with this a little bit more, is there a world, what would you need to change to be able to support the lifecycle style metrics, or is that even possible?
I just don't know that I want to be able to support them. I just don't know that I haven't tried it yet. That's all. But I do think it's possible. Like right now, I think the main thing is that you will likely need to do some kind of CTE, and I don't do CTEs, so. And there are definitely like blind spots in this thing, or like, you know, features that need to be rewritten or written to support like joins that do, like, if you have too many metrics, they might multiply, right? Or if you have too many of these, like, you know, these aggregations, they might multiply. We can detect those things and do, you know, like different stuff. I just wanted to start here and see what, like, you know, if we describe this to an LLM, what is it going to actually like spit out and, you know, like do here? So, yeah.
Yeah, because now it's all left joins, right?
Yeah. Right now, this is all left joins. Yeah. But also, like, you know, if this is actually good, then maybe, you know, like a lot of this, yeah. I don't know. Well, I don't know actually yet. So I just kind of want to see what an LLM does with something like this, understanding the semantic model as well. This whole system.
Cool. Because I'm going through this right now, do you think it's valuable to make sure that we are using column names consistently throughout? Like, I've noticed sometimes we will say contract address instead of artifact name.
I think we should try to make them consistent. The thing is that we can, you can write linters to actually determine that. Right?
Yeah.
So, yeah.
I know that there's a lot of stuff that isn't.
Yeah.
I mean, obviously those are breaking tables every time we do it. So,
I mean, I obviously like on it. Obviously, if in certain circumstances, it might make more semantic sense to keep, you know, like contract address in a contracts model, right? But yeah, I don't know.
I need to jump to a budget board call right now. Ray, do you want to do sprint planning 30 minutes from now? Would that work for you?
Yeah, that sounds good. I'm gonna grab something to eat, and we can
Okay.
meet up at 11:30. Sound good?
Cool.
Yep.
Sounds good.
All right. Thanks, y'all.
Yeah.
Hey.